Hi, I'm Amber. I'm a sophomore majoring in preclinical laboratory science. And a fun fact about me is that I love to read. I would like to continue to be a learning assistant because I really enjoy supporting students in their understanding of chemistry concepts and serving as a helpful resource for them. One way I will help students develop better learning strategies is by encouraging them to really understand the concept behind the problems that we work in class. Because if you're able to understand the concepts behind each problem, then you can solve a problem that you've never seen before on an exam. And today I will be working us through an acid-base equilibria question. So in this question, we are going to calculate the initial concentration of this weak acid that is needed to produce an aqueous solution with a specific pH. So I would start by highlighting the key information in the problem. So we're trying to find the initial concentration. We know this Ka value, and we're given the pH. So because we know that we're trying to produce this in an aqueous solution, we know that this acid is going to react with water. So we can write a balanced equation. It's important to include states because knowing those states will help us when writing our equilibrium expression. So this is the balanced equation. And from this balanced equation, we can set up our ice table. The initial concentration of that acid is what we're trying to find. So I'm going to label that as Y. We know that water is a liquid, so it won't be included in our Ka expression. So we can disregard it here. And we know that the base, the conjugate base, and the H plus are initially zero. Our change on the reactant side will be minus X, and our change on the product side will be plus X. Now notice we've highlighted key information in the problem, and we know that the pH of the aqueous solution when reacted is 2.8. So that means that we can find that H plus concentration using a formula that we know, which is that the H plus concentration is equal to 10 to the negative pH. So if we do this, we find that our H plus concentration is about 1.58 times 10 to the negative 3. So if we write that underneath, and this will be true for all of our x values in this problem. So we can go ahead and set up our Ka expression. Ka is going to be equal to the H3O plus times, oops, times the conjugate base over the acid. And because the conjugate base and the H plus concentration are both equal to X, we can just square that value. And we're going to set that all equal to our Ka value, which is 6.5 times 10 to the 5, to the negative 5, excuse me. Then we can cross multiply to solve for y. And if we square that x value, we get 2.51 times 10 to the negative 6. Then we can move this to the other side to isolate the y. 2.615. When we add that, we get 2.615 times 10 to the negative 6. And then if we solve for y, we get around 0.04023. And from that, we can get sig figs to be 0.040 molar. And that is our initial concentration of the weak acid needed to produce an aqueous solution with a pH of 2.80. Thank you.